Welcome to section 3.4. In this section and the next two sections, we're going to be talking about something called conditional probability. In this section, we'll define what conditional probability is and give some examples, as well as how to write it in notation, as well as the related concept of independence. In the next section, we'll talk about how to calculate conditional probabilities with some examples, and then we're going to conclude with something called the inverse problem, where we switch the probability and the condition. At the end of these three sections, you'll have a checkpoint assignment in which you'll be walked through the implementation of this through Excel. Consequently, instead of doing Excel during the videos, you're going to walk through it through the assignment and figure out how to do some of these things there. So let's start by describing what we mean by conditional probability. So let's think about an example. Suppose we want to consider the probability of getting stopped by a cop while somebody's driving. What might that probability depend on? Well, there's a whole lot of things that it might depend on. And we assume these are random. We're looking at a random driver. The speed of the car, whether they're driving a stolen car, the type of car or the color of the car. Some people think red cars are more likely to get stopped. If the driver's driving erratically, what time of month it is. Some people think that cops are more aggressive near the end of the month in order to meet certain quotas. Those are a number of possible conditions. And the way the probability depends on those conditions is what we mean by conditional probability. Let's focus on the example of speed, most common one. Right? So we've got a random driver, and the probability of them getting stopped might be different depending on what their speed is. So we're going to think about, since the driver is random, their speed is random. So if S is their speed, if S is less than the speed limit, they're less likely to be stopped in general. If their speed limit's 10 miles or less above the speed limit, maybe a little more likely, but also not terribly likely. But if they're driving more than 10 miles above the speed limit, I'd say they're highly likely to get pulled over. This is what we mean by conditional probability. And we say that whether or not you're getting stopped, the probability of getting stopped is conditioned on the speed S. In notation, we write P of, and then the variable, whether or not you get stopped, and then a vertical line, and then the variable that you're conditioning on, in this case, the speed. And we read this notation as the probability of getting stopped given the speed, right? And that vertical slash is written as given. So let's see what this looks like with just a few numerical examples. So these are just some hypothetical numbers that I dreamt up. So using this notation, if you're driving under the speed limit, and the probability of getting stopped is 5%, we say the probability of getting stopped given your speed is less than the speed limit is 5%. Why not 0? Well, remember there are those other conditions, stolen cars, erratic driving, things like that. But those are a lot less frequent. So the probability that a driver is stopped given that they're driving less than the speed limit is pretty low, and I said in this example it's 5%. The probability of getting stopped if the speed limit is less than the speed of the driver, which in turn is less than speed limit plus 10, we're going to say that's a little bit higher, 6%. And that means if you're driving 10 miles or less above the speed limit, your probability of getting stopped is 6%. Still pretty small. Remember, there's other conditions, but it's a little bit more likely than if you were driving less than the speed limit. Finally, the probability of getting stopped if your speed is larger than the speed 10 miles over the speed limit, I said would say 73%. So highly likely. Right? You drive by a cop, and if your speed limit's 10 miles or more larger than the speed limit, they're probably going to pull you over unless they've got something else that they're responding to. Now, I wrote this not a great example because the condition, the speed, should be a random variable. And as I started, because I was imagining it's you driving and it's your speed, which you have control over. But if you think about the driver as a random driver, then the speed is a random variable, and now we recover this is a better example. Here are a few other examples. The damage, if you're playing a game and you're fighting a boss, the damage you are able to inflict on a boss might depend on the random place where the boss is spawned. Right? Certain places you may be more likely to do more damage. The number of customers you have might depend on the weather. And the probability of getting a cavity might depend on how much your teeth have been exposed to bacteria. All of these are examples of probabilities given a condition. In the next video, we're going to talk about something related to conditional probability, independence.